Welcome to the DIY Honda Garage channel. The DTC P0335-1F and P0339 indicate an issue with the Crankshaft Position CKP sensor circuit, specifically an intermittent interruption. This diagnostic trouble code, DTC, is triggered when the engine control unit, ECU, detects abnormal pulse patterns in the reference pulses from the CKP sensor. The CKP sensor itself is a critical component that monitors the position and rotational speed of the crankshaft, providing necessary data for precise engine timing and fuel injection. It is typically located near the crankshaft, and any disruption in its circuit can lead to engine performance issues. According to the diagnostic guidelines, prior to troubleshooting, it is crucial to familiarize oneself with the relevant manuals and inspection outlines, as this lays the groundwork for effective and structured diagnostics. Failure to address this issue could result in erratic engine behavior or even engine stalling. The Crankshaft Position CKP sensor plays a vital role in engine operation by monitoring the crankshaft's positioning and its speed. Located generally at the front of the engine block, near the crankshaft, this sensor sends signals to the Powertrain Control Module, PCM. The PCM uses these signals to maintain appropriate fuel delivery and ignition timing. If there's an abnormality in the reference pulses sent to the PCM, it will identify that there is an issue with the CKP sensor circuit and store DTC P0335-1F or P0339. It is essential for the CKP sensor to produce regular pulses. Any interruptions will lead to potential misfires, reduced engine performance, and increased emissions due to improper timing of the combustion process. Therefore, ensuring the integrity of this circuit is crucial for optimal engine function. The causes of DTC P0335-1F and P0339 commonly include loose connections at the CKP sensor, a malfunctioning CKP sensor, or damage to the CKP pulse plate. Loosening or poor connections at the sensor can lead to inconsistent signal transmission, which confounds the PCM's ability to gauge the crankshaft position accurately. A faulty CKP sensor, whether due to age or damage, may also fail to provide the necessary signals, leading to intermittent readings and triggering this DTC. Additionally, if the CKP pulse plate becomes damaged or dislodged, it can disrupt the flux of signals between the sensor and the PCM. Each of these elements plays an essential role in ensuring that the engine runs smoothly, and failure in any of them can lead to significant performance issues. When the P0335-1F or P0339 codes are triggered, symptoms may manifest as engine stalling, rough idling, or diminished overall engine performance. These symptoms arise because the CKP sensor's inability to provide accurate readings hinders the PCM from executing optimal fuel injection and ignition timing. Consequently, the engine may struggle to maintain stable operation, resulting in a rough idling condition where engine speed fluctuates unexpectedly. Moreover, drivers may notice a significant decline in acceleration and responsiveness when attempting to accelerate, indicating that the engine may not be firing optimally. If not addressed in a timely manner, these symptoms could worsen, leading to more serious engine issues and potential safety hazards while driving. The first troubleshooting step for diagnosing DTC P0335-1F or P0339 involves starting the engine and allowing it to idle for a minimum of 10 seconds. This action simulates the operating conditions where the CKP sensor should be yielding stable pulse readings. During this idle period, the Honda Diagnostic System, HDS, is monitored for the presence of DTC P0335-1F or P0339. If these codes continue to appear in the HDS, It indicates that the issue lies within the CKP sensor circuit or its related components, necessitating further investigation. This initial step is crucial in verifying whether the issue is persistent and guides the technician to the next phases of diagnostics or repairs. Engaging the HDS aids significantly in collecting data about the current conditions of the vehicle. The second step in the troubleshooting process requires a test drive of the vehicle for several minutes under conditions matching those that are present during the recording of the onboard snapshot parameters. During the test drive, it is essential to pay attention to both engine speed and vehicle speed. Monitoring these parameters allows a technician to capture real-time data reflecting the vehicle's performance, specifically looking for the reoccurrence of DTC P0335-1F or P0339. This step is significant in identifying whether the CKP sensor exhibits any intermittent failure during standard driving conditions. If issues manifest during this test, the subsequent steps can clarify the root cause by guiding focus towards specific components identified in prior inspections or tests. In this step, the focus shifts to the connectors related to the CKP sensor. Inspecting these connectors is crucial, as loose or corroded connections can lead to signal interruption between the CKP sensor and the PCM. A secure connection is essential for reliable data transmission, which determines the sensor's functionality. During this inspection, one should also verify the terminals for any signs of looseness or damage. If abnormal connections are found, they must be rectified to ensure proper sensor operation. Making sure that these connections are in good condition may resolve the DTC without necessitating further inspection of other components on the circuit. Any findings here may simplify the troubleshooting process. The fourth step entails checking the CKP sensor circuit terminals to ensure that they are securely connected and in good condition. It is vital to assess the engine ground and body ground terminals during this inspection. Poor grounding can lead to erratic behavior of the CKP sensor, which in turn affects the PCM's ability to interpret the data correctly. Ensure that there are no signs of corrosion, wear, or damage in the terminals, as these could also induce intermittent connectivity issues. Any abnormalities noticed must be addressed to restore proper function. This step reinforces the importance of a well-maintained electrical system in the vehicle, which is key to ensuring reliable signal transmission. Resolving any existing issues at this stage may eliminate the DTC entirely. The fifth step requires performing a visual inspection of the CKP pulse plate, which is a critical component for ensuring accurate readings from the CKP sensor. The pulse plate should be examined closely for any signs of looseness, wear, or visible damage. A compromised pulse plate can disrupt the interaction between the CKP sensor and the crankshaft. This disruption could result in erratic or missing signal pulses, ultimately leading to the triggering of DTC P0335-1F or P0339. If any issues are identified in this inspection, the pulse plate will need to be repaired or replaced to restore optimal sensor function. Ensuring the pulse plate's integrity is crucial, as it directly impacts the reliability of the CKP sensor and overall engine management system. The final troubleshooting step involves a detailed inspection of the CKP sensor itself. If all previous inspection items indicated normal conditions, yet the DTC still persists, it is reasonable to conclude that the CKP sensor may be faulty. This component's role is critical. If it fails to generate accurate signals, it could indirectly affect engine operation significantly. Thorough testing should include assessing the sensor's electrical resistance and functionality to ensure it is compliant with manufacturer specifications. If abnormalities are found during this inspection, the CKP sensor should be replaced. Ensuring that the CKP sensor is fully operational will directly contribute to restoring proper engine timing and efficiency, thus resolving the DTC effectively. After executing the necessary repairs based on previous steps, it is essential to conduct a final verification. This includes clearing the DTC codes from the Honda Diagnostic System, HDS, and running the vehicle to observe its operation. Monitoring the vehicle's performance during a test drive allows one to ascertain whether the DTC P0335-1F or P0339 reappears. Additionally, verifying the engine operation will confirm that it is running smoothly without any symptoms of stalling, rough idling, or diminished power. If no codes reappear and the engine operates normally, it is an indication that the issue has been resolved adequately. If issues do persist post-repair, further investigation may be warranted, focusing on components or connections that may have been overlooked during initial diagnosis. Preventive maintenance is crucial for avoiding issues such as DTC P0335-1F or P0339 in the future. Regularly checking electrical connections, especially those related to the CKP sensor and its circuit, can help prevent loose or corroded connections that might lead to intermittent performance. Additionally, monitoring the performance of the CKP sensor during routine maintenance checks can help in early detection of any abnormalities. Keeping an eye on the health of the pulse plate and ensuring it is free from defects will also bolster reliability. Following the manufacturer's guidelines for service intervals and using quality components aids in sustaining optimal vehicle performance. This proactive approach can significantly extend the vehicle's longevity and reduce the likelihood of costly repairs. In conclusion, the crankshaft position CKP sensor plays an essential role in the engine management system, providing critical data needed for optimal engine performance. Understanding the implications of DTC P0335-1F or P0339 and acting promptly to troubleshoot can prevent further complications. Systematic troubleshooting, starting from initial diagnostics to thorough inspection of connectors, terminals, pulse plates, and finally, the sensor itself, is vital for resolving the issue effectively. Regular preventive maintenance can help ensure that the CKP sensor and associated components continue to function smoothly, thus safeguarding against future problems. By adhering to the outlined procedures and practices, vehicle owners and repair technicians can ensure reliability and performance in the Honda CR-V and maintain its operational integrity. Please like and subscribe to the channel. See you next time.